So today we have two questions here that we will solve. The first question, we are given a system with 5 samples, and here you can see the X bar for each sample, which are, and the R, which is the range for each sample. And once we have those values, we are asked to draw an X bar chart and an R chart, which is a range chart and an average chart. And after that, we are asked to also calculate the CK and the CP. And for that, we have to do the following steps. Now, as you see here, first of all, we need the X grand, which is the X bar grand, and the range grand. And in order to calculate that, we just need to get the summation of the X bar values and divide it by the N, which in this case we have 19.5. Same for the range grand, which is the summation of the ranged value, and divide that by N, which is 10 in this case. So 5.9. And now we need the upper limits, upper control limits and lower control limits beside the control limit. The control limit is the same of the X bar grand and the range grand. So we will not calculate that part. We will only calculate the lower and the upper control limits. Now, for the upper control limit, for the X bar chart, this is the equation. It's basically X bar grand minus A2, which is a given, and the R grand multiplied by the R grand, which is, here you can see the calculations, and this is the upper control, the lower control limit. Now for the upper control limit, on the other hand, we have only one difference, which is here we will add it, not subtract it, to the A2 multiplied by R bar grand. And in this case, you have the lower control limit of 22.9043. And this in the range limits, we have different equations, which are, for the lower control limit, you will have D3 multiplied by R grand, and the D3 is also a given, which you can get from a table with the N size, which is, in this case, is 10. So from the table, the D3 is a given, it's 0, and for the upper control limit, you will need the D4, which is in this case 2.11. So you will get the upper control limit and the lower control limit for both the X bar chart and the R chart. And as I said before, the control limit, CL, is the same as the grands. And now, in order to draw this chart, first of all, as you can see from this table, you can see there is 10 N's, and here you have the values of the X bar, and here you also have the values of the range. So we'll go back to the chart, and as you can see here, first of all, we will add the 10 values, and here we do the same. And now we have to add the lower control limit, the control limit, and the upper control limit. Now, as we calculated before here, from the X bar chart, we have the upper limit control of 23, which is the approximate of, where was it? It was here, 22.90. So approximately it's 23, and then you have the lower control limit of 16. So you have these lines, and as I said before, the CL is the same as the grand, which is 19.5, so we have it here. Now, in order to draw this chart, we need those points. Now, these points, we get it from also the table. So, as you see here, the 1 is the number 1 value here, and you will take each value and draw it correspondingly to its position. So 18.6 from the table here, we will look here and we will add it here, and we will do the same for the rest, and then you will get this graph. Now this graph, as you can see, the values are around the center line, the control limit, sorry, and it doesn't approach the upper control limit or the lower control limit or go past it, which is a good thing. And basically the same thing will apply for the range chart, where you have to do basically the same thing, but with a different lower control limit and the upper control limit, also a different control limit here. And as I said before, here we get them from the calculations we did earlier. We have the upper control limit for the range chart as 12.44, which is approximately 12.5, and the lower control limit of 0. And as you can see, we take each value from the ends, and you can see the values here. So 3 is corresponding to 1, so we will add 3, a point here corresponding to 1, and then we will do the same for the rest of them, and you get this chart. Now, finally, the second part of this question is how to calculate the CPK value and the CP value. Now, first of all, we need the sigma, because as you can see here, the CP, the formula of it is upper specific limit minus lower specific limit over 6 sigma, which is 6 multiplied by sigma. So basically, and as you can see here also, for the CPK values, we will also need the sigma. Other than that, the USL and the LSL, which is the upper specification limit and the lower specification limit, is given in the question. So we don't need to worry about that. Now, how to get the sigma? Sigma is basically the standard deviation. And the way you calculate the standard deviation is getting each value from the X bar from the table, each value minus the value of the grand X bar, and the answer will be squared. And then you will add that to each summation of the X bar minus the X bar grand, and also square it again. You will understand better from an example. Let's look at here. Here you can see we took the X bar value from the table minus the X bar grand value, and it's all squared, plus we took the second value from the table, which is 18.4, minus the X bar grand, all squared, and we will do a summation of all the values. Now, at the end, we will divide that by 10, which is the n value, the sample size, and then we will take the square root of all of that, which is in this case, as you can see here, it's 1.040. Now, once we have the sigma, here it's actually really easy. You just follow the formulas, and for example, for the CP, you will get 30 minus 10, which is our specification limits, divided by 6 multiplied by our sigma, which is in this case 1.040. So now that we have the CP value, we need the CPK value. Now the CPK value, in order to get that, basically it's the minimum between the CPU and the CPL. Now what is the CPU and the CPL? The CPU is the upper CP and the CPL is the lower CP. And the way we calculate that, for example, let's take the upper CP, which is its formula is basically it's USL minus X grand, which is the X bar grand, divided by 3 sigma. So USL is given to us in the question, which is in this case 30, minus the X grand, which is 19.55 that we calculated earlier, and divide that by 3 multiplied by sigma. Sigma, we also calculated that earlier, which is 1.040. And the answer will be, in this case, 3.365. Now, the CPL is kind of the same equation, but instead of having USL, we will have the LSL, and we will subtract the LSL from the X bar grand. And in this case, we will get 3.044. Now, as I said before, the CPK is the minimum between the two, which is in this case 3.044. And now what does that mean? What it means is that, as you can see here, the ideal CPK is 2.0, which is a given. And our CPK is 3.044, which in this case, it means that whatever those values are returned to, let's say a company or something, those values means that, let's say as an example, it's a company. In this case, this company is capable of keeping stability. And if they were lower than 2.0, it means that it's not capable of keeping stability. Now, for the second question here, we have, let me organize this real quick. So, in the second question here, we have basically, we need to draw the operating characteristics curve, and in order to do that, we have the certain p-values which is given, and we need to calculate the PA for those values. And another thing we should calculate is the AQL, and we have the acceptance value of 0.95. Now another thing that is given is the N, which is 18 in this case, and the C is 0. Now, what does that mean? Now, as you can see here, in order to calculate the PA, there is this formula that we have to apply. And in this formula, you can see the summation of n factorial divided by d factorial and n factorial multiplied by p to the power of d multiplied by 1 minus p to the power of n minus d. Now, just to clarify something, the c here is the d, and the n capital here is the n small here. And now that should make things a little clearer. And by the way, the p here is the p given to us here. So as you can see, it's just you will just put the values in place. So the n, which is given to us, it's 18 factorial divided by d, as I said before, it's the c. So it's 0 factorial multiplied by 18 factorial, which is the n here, multiplied by p, you can see the p here, to the power of d, which is c, which is 0, and so on and so forth. Now, there is something that you should notice here, which would make those calculations really easy. As you can see, we have n over n, which could be omitted together. And you can see here, the d value, it's 0. 0 factorial is 1. So basically, all of this side will be equal to 1. And you can see it's repeated in all of them. So this side will always be 1, multiplied by also this side, it's to the power of 0, which means it's also 1. So you have 1 multiplied by this part. So what that means is that we don't even need to calculate these parts. All we have to do is calculate this part only, which is, in this case, 0.9995 to the power of 18, which is this, not 0.9910. And we will do the same for each and every single p-value. Now that we have our p-values and we have our PA values, all we need is the AQL value. Now, in order to calculate the AQL, basically we have this formula. It's y equals 1 minus x, which also could be 1 minus x equals y, which is this. So, what does that give us? As you can see here, we have the PA, as I said before, we have it given, the acceptance, as 0.95. Now, we will solve it according to the first formula that we looked at. Now, we know that the n is 18, the d is 0, and the n here is 18 again. Factorial multiplied by p to the power of 0, which is the d, multiplied by 1 minus p to the n minus d, which is the same. Everything that I said here will also apply here. So what we really need to calculate is this part, right? So in this case, if you put this number and you have the x to the power of 18, that means we should take the root of 18 to this number and take the root of 18 to this number to get rid of this, and we will get the value of x. Now once we do that, the value of x is the following. And since we have the formula y equals 1 minus x, we can get the y value since we have the x value. Now the y value is this number, and you can see that is the AQL. Now once we have those values, in order to draw a chart of those, all we have to do is put the p values and the PA values. Now the p values will be shown right here, and we will take the approximation of of those very small values. We will not add them because they are extremely small and they will not fit in here, which is the 0.005, 0.0025, and 0.005. So we'll start from 0.01 all the way to the 0.09. And as you can see here, we did that. and the PA values will be put in the left, which is the result of the whole formulas. And now we need, in order to draw this graph, we need to point out where each PA value corresponds with the P value. So for example, let's say the 0.005, which is extremely close to the 0, its value, the PA value is 0.9910, which is extremely close to the value of 1. So as you can see here, if you look closer, I've put a dot at the 1 value, which is the PA of 0.9910. And it's so close to the 0 of the x-axis because the P value here is 0.005, which is very close to the 0 value. So we will do the rest for all of them and we will get this graph. Thank you for listening.